Okay, so section 5.6 and section 5.7 have been pretty intense. We've learned a lot of new stuff. Let's go through some of the things that we've learned just to summarize it all and put it all in one spot. We learned about absolute value inequalities. Now we said these come in two types. They come in less sandwiches, which is where you have an absolute value with a less than or a less than or equal to symbol, and then the number. When this happens, we said you put the inside stuff in the middle, the less than or the less than or equal to symbol on either side, and then you put the positive number and the negative number. We called these sandwiches. In contrast, sometimes we have what are called great or than problems. This would be when you have an absolute value and you have a greater than or equal to symbol and then the number. When this happened, we called these or problems. You're going to copy the original and then put the word or and then take everything from the original and flip it over and make the number negative. Now the two things are changing here. We're flipping the symbol and we are making the number negative. All right, let's try two examples. So, first we need to isolate the absolute value. Let's start by adding 5 on both sides. Pull this down a little bit. When we do that, we get negative 6 times the absolute value of x plus 3 is greater than negative 12. Then we need to divide both sides by negative 6. Now I'm dividing by a negative. So this symbol is going to flip over and become a less than. As soon as I see a less than, I think less sandwich. So the x plus 3 goes in the middle. Less thans go on both sides. The positive 2 goes to the right and the negative 2 goes to the left. This is sort of like phase 2. Now I'm going to solve. So I'm going to subtract 3 on all 3 sections, and I get negative 5 is less than x, which is less than negative 1. And that's my answer. To graph that, I put an open circle on the negative 5 and an open circle on the negative 1, and I shade in between. Problem number 2. Again, I need to isolate the absolute value. So I'm going to subtract 7 on both sides, which means I get negative 2 times the absolute value of x minus 2 is less than 10. Then I'm going to divide by negative 2 on both sides. So I get the absolute value of x minus 2, and I divided by a negative, so this is going to flip and come a greater than negative 5. As soon as I know that it's a greater than, I know that I need to make two problems. The first problem will be the same as the original. Then the word or will go in between. And the second problem, I'm going to flip the symbol and make it a positive 5. All right, now I'm going to solve. So I'm going to add 2 on both sides, so x is greater than negative 3, or I'm going to add 2 on both sides, so x is less than 7. Oh golly. I am so sorry, guys. This should have been a negative 17 at the beginning, which makes this a negative 24, which makes this a positive 12, which means this should have been a 12, and when you add 2, this will be 14, and this should have been a negative 12, and when you add 2, you get negative 10. I am so sorry. That must have been a typo on my part. I was wondering why the answer was working out a little bit weird. Oh well, we fixed it. So basically it just changes the numbers. You don't change the process. Now I'm going to graph. So open circle on the 14. Just going to draw in some extra spaces there. And open circle in the -10 and shade to the outside. Let's just take a second, make sure you made all the right changes. Okay, now in addition to learning about solving absolute value inequalities, we learned about graphing linear inequalities. We said first you need to isolate the y. Then you graph the slope and the y-intercept. Then you determine whether you should make it a solid line, which is when you have an equal to, or a dotted line, which is when you do not have an equal to. And finally, you decide between shading above, which is a greater than, or below, which is a less than. Now, don't forget about Vuxhoy, because sometimes graphing these lines has sort of special circumstances to make that happen. So, to summarize, solid, greater than or equal to, less than or equal to. Dotted, greater than or less than. Above, greater than or equal to. You have to be greater. Below, less than or equal to. Let's try a couple examples. So in number 3, I would definitely need to get the y by itself first. I'm going to copy the problem down so I have space to be neat and organized. I'm going to subtract the 2x on both sides, and I get negative y is greater than negative 2x plus 4. Finally, I'm going to divide everything by -1. Now, when I do that, the symbol flips over, and I get positive 2x minus 4. I'm going to put a closed circle on the -4, up 2 over 1, up 2 over 1, up 2 over 1, down 2, left 1, down 2, left 1. I'm going to make this a dotted line because we're not equal. And I'm going to shade below because there's a less than. Let's try number 4. So for number 4, once again, I'm going to need to get the y by itself. So 3x plus 2y is less than or equal to 6. I know I'm going to subtract the 3x on both sides. So I get 2y is less than or equal to negative 3x plus 6. And then I'm going to divide everybody by 2. So y is less than or equal to negative 3 over 2x plus 3. Now I'm going to plot a point on the 3. Down 3 over 2, down 3 over 2, down 3 over 2. Or up 3, left 2, up 3, left 2. I'm going to make this a solid line because there is an equal to, and I'm going to shade below because it's a less than. So solid line, shade below because it's a less than, would be this part of the graph right here. That sort of encapsulates everything we've learned in section 5.6 and 5.7. Obviously, it was kind of a lot to practice, but hopefully this helps to put all the pieces together.